calculation, and as I said that we'll be doing on the equation of state based approach, and let's see that. So that you can actually straightforward, you can it is possible because we have already done the gives energy departure, and I will give the final formula so we can go back home and try to derive the fugacity expression based on equation of state. And we know how to do it the direct way from the departure formula, which is m minus mij dp. You know that is integral p equal to 0 to p dou m by dou p prime dp prime minus p tending to 0 to p dou mig by dou p prime dp. That's the way we can do that. And here you know that the formula is v minus rt by p prime dp prime for the interfugacity calculation. Or you can actually have the formula of the, there is a verification purpose, I will not actually appreciate that to do of the manipulation of that's g equals to h minus ts, you can say g minus gig equals to h minus hig minus t into s minus sig. That I will ask for. Directly go for the definition. You can fill for that whatever do. Okay, so the van der Waals equation of state, we have ln phi, which is z minus 1 minus ln mod z minus b minus a by rt, which is, and where b equals to vp by rt, capital. Similarly, you can have Redlich-Kwong RK. You can prove it. Proving is very easy. I am not doing it in the class. We have done it so many times. All this proof of h minus hij, s minus sig. And similarly, you can get even phi for Redlich-Kwong equation, which is z minus 1 minus ln mod z minus b minus a by b rt ln mod z plus b by z. Okay. We can have SRK, which is ln phi equals to z minus 1 minus ln mod z minus b minus a by b rt ln z plus b by z. Same formula, RK and SRK, and then formula is a bit bigger for the Peng-Robinson equation of state. Peng-Robinson equation of state, which is ln phi equals to z minus 1 minus ln mod z minus b minus a by 2 root 2b rt ln z plus b into 1 plus root 2 by z plus b into 1 minus root 2. That's it. And this formula can be easily, these expressions can be easily derived. That you can actually go back home and do it. It is not that difficult. Okay, so we are talking about the we talked about the Maxwell's equal area rule, and based on that, so many things actually come, and we found that calculation of fugacity is very, very important. And one thing actually we want to mention that, because this is the PV diagram. If you draw from the cubic equation of state, okay, this is the diagram, and this is mathematician's diagram. Physicists will say that physicist diagram is like this. So we need to have a point where that is called P sat, such that this area and this area will be same, and you can say that this can be nullified and your equation of state is like this. So this P sat calculation is very, very important. What is your P sat? How to calculate? So the question is, so that is what I taught in the class. All the all your calculation is based on the trial error, but there is more formal way to calculate this P sat. So we can here we discuss about how to calculate P-sat. How to calculate P-sat. That's what I am going to discuss here. So, and we'll go by something called iterative approach. Iterative approach. So, calculation of fugacity. Calculation of fugacity in liquid phase. This is the first step. So what we are going to do here, very simple, is a vapor liquid equilibrium, right? This one. Okay, this is your VL, this is your VG, and these 2 points, phi L equals to phi B. So our basic principle to calculate this P-sat is phi L equals to phi B. That's basic principle. Phi L equals to phi B. So when you talk about liquid phase, the phase change will occur at the P-sat and go to vapor phase. The phase change, so focus in liquid phase and vapor phase. And remember that vapor phase fugacity calculation is very straightforward, but the liquid phase is not that. That we will discuss now. So what we can do that is we talk about iterative space. What is iterative process? Iterative process we have seen Newton-Raphson method. What is Newton-Raphson method? This is a curve, this is a root here, right? Newton-Raphson method, you take initial guess here. Okay? This is your initial guess, x0. You are solving for fx equals to 0. Right? So draw a tangent. Okay? And it goes here. x1. You draw a vertical line. Again draw a tangent from here. x2, and that's it. Fx once, and every iteration you can calculate fx, whether it is 0 or not. If it is 0, that's it. Fx2 you are defining 0, that's it, you got the solution. It may not get direct 0, it may get in the -5, in the -6, doesn't matter. You put some tolerance limit and say that okay, this is my this. It says what? It says along the near the solution, it is linearly valued. That means if I have a straight line, wherever you take the initial guess, doesn't matter, in one iteration should get the solution. One iteration should get the solution in one iteration. If it is not linear, then you have to go for the mode. Okay? So for this, we are actually allowing the solution to go by linear, and that's why if you look at Newton-Raphson method, it is x nu equals to x old a prime x old by fx old. Am I correct? Yes or no? Okay. So this actually shows this something like your linear relationship. Actually it is well. Fx or f prime. Just check it out. Correct? Fx or by f prime x or. Okay. So this actually says, and you can prove it. You can prove from Taylor series. You can prove from Taylor series this one. So you are saying that linear relationship is valid. So this is for iterative process. So similar iterative process, is it possible for calculation of P-sat? We look into the iterative process to find out whether a similar kind of thing can be possible for the fugacity for the paper P-sat calculation, or saturation pressure calculation. So what the iterative process we do? This is the place where you have P-sat. So you can have a place here, you can have a place here. So here means your curve is like that. Here means your curve is like that. So this is the I point, this is I prime point. So it can go this direction, such that your fugacity is safe. Okay, such that the vapor liquid flow. If it is not, then fugacity will not be safe, and that means you are not in vapor liquid equilibrium. If you have to check for another P-sat, and that P-sat vapor liquid equilibrium will be valid. That means phi L equals to phi B, right? Phi L equals to phi B. So at convergence, we have Pi equals to Pi prime equals to P-sat. At convergence, Pi equals to Pi prime equals to P-sat, right? At convergence, Pi equals to Pi prime equals to P set. So, what you will calculate? We have to investigate whether phi I question mark is phi I prime. We have to investigate whether phi I equals to phi I prime or if I equals to phi prime. If it is, that means you are exactly the same line, right? They are exactly the same line. So fugacity at liquid at point I prime. What's my fugacity formula? Remember? Do you remember the fugacity formula? ln f by p equals to ln f by v. I said ln f by p. Don't say the exponential. You just listen and then talk. ln f by p is nothing but mu minus mu ig by rt. Okay? Or rt ln f by p equals mu minus mu ig. And mu minus mu ig is nothing but integral p0 to p v minus rt by p prime dp prime. Those things you should actually remember from heart. So fugacity, it will be rt ln fl. You can just put phi l phi b as greater fl by pi prime, which is the departure of chemical potential, right? And departure of chemical potential is p equal p tending to 0 to PIT, which is okay. What should I write? Pi prime or whatever. What should I write the formula? Maybe I should not write. You should write. I should not write the formula. It is mu minus mu I GTP, and mu minus mu I GTP, you know that integral. So for your benefit, I write the formula here. We all know mu minus mu IG PP, which is P equals tending to 0 to P V minus RT by P prime dP prime. I want to write this other items. What should I write? How many terms will be there? 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 Liquid phase fugacity. Okay, fugacity of vapor you should write. Fugacity of liquid of vapor at point I, which is RT ln FV by PI. What should I write? Vapor means here and P tending to 0 is here. What should I write? Vapor. It should be very easy. It should be very easy. It should be very. Who will volunteer? It should be very easy. Right hand side. Yes, madam. P tending to 0, Pi, V volume, V of vapor, V of G you can say, minus RT by P prime dP prime. Equation number 2. Now tell me the liquid. What is your path? This is the path for the fugacity calculation. Okay? The fugacity calculation can see the path. So that's why fugacity is thermodynamic property or not? Another question comes. Is fugacity a thermodynamic property? Yes or no? Is fugacity thermodynamic property? Yes. How is it possible? In the first part thermodynamics you can see Q minus W equals to delta U. This is thermodynamic property, these are not, right? Okay. Now tell me the answer. Is fugacity thermodynamic property? Think about it. I won't give you the answer. Maybe the exam question. Okay. FL by Pi prime. FL by Pi prime. What is that? For liquid phase. How many terms will be there? 2. Okay. Who said 2? This is the right answer. Okay. Can you tell me the answer? 2 is the right answer. But I want the answer. Can you be a bit louder? If you are not louder, there is problem. Even for a getting job, they will ask you to talk louder and clear. Anybody else can volunteer? 2 is the right answer. 2 is the right answer. But how to do that? What's the path? Can you tell me the path? How to come to this point? How to come to this point? This from here to here. From here, okay. And then if you assume that this is the path, you can come here. Okay? And along this path, there is no integration because it is integral V dP. Okay? And P is constant. Okay? So it is actually having the same limit of pressure. Lower limit, upper limit, same in the integral. So this path will not contribute to the integral. That's the maximum equal area rule. Even if you follow that path and same path, because the area is 0, the same, you can actually go by this path. That's what we have proved earlier. The maximum equal area rule, right? So, what is your expression? I have given the answer actually almost. I have given the answer. I have given the answer almost. Who can give me the answer? Who can give me the answer? Only 2 people actually raising the hand. That's all. That's what I'm saying. I'm maybe teaching for 2-3 people in the class. Others are just keeping quiet. What is the answer? 2 terms I'm asking for. You are saying, I am saying the path. Now I'm really surprised. I'm really surprised that you are not. What is the path? Ideally speaking, this I prime, I can directly write fugacity at this point. Without knowing the path, I can say it is V minus RT by P prime dP prime 0 to Pi prime. This is my ideal expression of fugacity at this point, right? From definition. Agreed or not? Yes? Agreed. But for this thing, I need to have a path. Is the path defined? If my point is here, okay, I say point is here. Is there any path directly? No path. Nothing is there. It is just like a road. There is no road here. All buildings are there. My road actually is here. My road is here. Okay. So, how to evaluate this? Yeah.
From the equation P tends to 0 to Pi.
Yes. 0 to Pi.
GL minus RT by.
What is that?
V, sorry, VG minus RT by P prime dP
Plus
from Pi prime.
From Pi prime. What are you doing? You are coming here. Then where are you going?
Pi.
What's the lower limit and upper limit? Don't prompt because when I asked you didn't tell me the answer. At least he is trying.
Sorry, Pi.
Yes. I don't like you to prompt because at least he has got the courage to give me the answer.
Pi to Pi prime.
Yes. Put temperature is better. Then
V minus.
what V? You should not say V. There is something. V. Which branch?
PL.
Yes. VL minus RT by P prime dP prime. So I have to put so much of effort to get this answer. It's too much. So much of effort I had to put to get this answer. Correct? So we are going up to this, and then I am assuming that here at this point we have saturation. Okay? So if I go here, because this could be Psat or this could be Psat. This I could be here also. I could be here. Okay? I could be here. Doesn't matter. Okay? And I prime could be here. Whatever. So equation 1 and 2, if you look at what you can see of equation 1 and 2. Equation 1 and 2 you can see these parts are same. First term is same. Okay, so and we know that Fl equals to Fb at the saturation. So PIT to Pi prime T, which is Bl minus RT by P prime dP prime, which you can write as PIT Pi prime T, which is Bl dP prime minus RT ln Pi prime T by PIT. Equation number 2a. Agreed or not? Very simple. Correct? Agreed. Equation 1, 2 and 2a. If you combine, what you will get? Equation 1, 2 and 2a. Equation 1, left hand side is RT ln Fl by PIT equals to. You can write in terms of fugacity in the gas phase, right? First term, which is RT ln Fb by Pi prime T, right? Then these two terms will be coming. What is that? Plus RT ln Pit by Pi prime T. Then PIT to Pi prime T Bl dP prime. Correct? This is P plus because I am just coupled it. These three terms I can put it one side. It's better. You can combine it nicely. And this term I just keep it here. The three terms, they don't have any integral. So easily to combine, and you have ln equals ln A by ln B equals ln A by B equals ln A minus ln B. All these formulas you usually combine together, and we can write this as ln Fl by, this is Pi prime. Sorry, please correct this one. Ln, and this is Pi. Okay. Pi prime T Fb by Pi. What is this term? You have to tell me. Equals to Pit Pi prime T Bl dP prime. What is this term? What is this term? Some other term is there. This is coming from here. ln A minus ln B is ln A by B. This also is coming. Some term will be there. What is that? What is that? Pi prime T by Pit. Okay? Correct? 1 by RT is there. So we can actually have exponential 1 by RT. Equation number 3. This is called as Poynting pressure correction. Poynting pressure correction. This is called as Poynting pressure correction. What it says that if Pi and Pi are very close, that means P sat. Pi goes to Pi prime means they are very close. Okay. This means very close means they are actually same place. So in that case, what actually happens? This goes to 0, right? And then your iteration starts. Let's see. If we assume it goes to 0, like your Newton-Raphson method, we assume linear behavior. If you do get linear behavior, that's the actual assumption that you have the solution. Then you get the exact solution after one step. But if you don't get, you can periodically get the exact solution. So this is called Poynting pressure correction. This Poynting pressure correction is important if you calculate the fugacity, if it is not in equilibrium. Okay, if you are 1 point, if you want to calculate the fugacity, if you know this vapor, so in that case you can actually do the Poynting pressure correction. I will come later on all those any kind of calculations. But here, if you have the Poynting pressure correction factor 1, that means integral is 0, in that case you are at equilibrium. So what will be iterative procedure? Iterative procedure is iterative procedure will be FL by Pi prime t into Pi prime t by Pi t equals to FB by Pi t. Agreed or not? Yes? At equilibrium. This is at equilibrium. At equilibrium, our assumption is Pi just like Anderson method. So we get x nu equals to x whole plus f prime fx whole by f prime x whole. That is how are you getting it? Because your iteration process is a linear process. Okay.
So we are taking pointing correction factor 1.
Yeah, because we are assuming that we are at equilibrium, just like this process. Okay. This is, I am saying my this thing is linear. So if you look at fx nu, the Taylor series fx whole plus x nu minus x whole by f prime x whole. Higher order term I am neglecting. Okay. Now I am assuming that at x nu I am getting solution. It is possible in the if a linear curve. Right? If a linear curve, then this is my x nu. Directly, whatever x whole you put along this, draw tangent to the tangent. Okay? This solution. So what you will get? X nu, this is the derivation of this. I didn't want to do that. Minus fx, see, I am also getting the correct result. I think the result not I given wrong. So it is x nu equals to x whole. I don't remember the formulas. I know only how to derive it. This is the right formula. So please correct it. I don't know how to remember the formula because my memory is very limited. I know how to derive it. This is the actual derivation. That means at each point I am assuming that x nu equal to 0 here. Same thing here. At each point I am assuming that my equilibrium is achieved and Pi prime equals to Pi. Okay. If I do that, so did you correct that international formula? Okay. So that is Pi prime. So Fl, I will say that P nu equals to Fb P old. Okay. So we have the iteration scheme now. P nu equals to at temperature T equals to P old temperature T Fl by Fp. Once you get P nu, just like Newton-Raphson method, P nu to be assigned as P old. Do the calculation. Get P nu, and once your P nu equals to P old, that is your P sat. Are not clear? This is the way one can calculate the saturation pressure. Iterative process. This is the way one can calculate saturation pressure. So if Pi prime not equals to P sat, then Fl by Fv sat will be what? If Pi prime is not equals to P sat. If Pi prime is not equals to P sat, what will you get? But Pi equals to P sat. The situation is exactly, I am here, but this point is not here. 2 points. What formula you get? FL by Psat exponential 1 by RT integral Psat to P prime dP prime. So you can write, actually this you should write FL Psat. This is already saturation point. So FL equals to Fsat Weber or Fsat exponential 1 by RT Psat P real. So liquid fugacity. Now that means if you know saturation fugacity, you can calculate liquid fugacity. Okay. That is another expression. So you may be asking that what's the use of this Poynting pressure correction? You can actually get FL using the Poynting pressure calculation if you are in a saturation point calculation. Okay. With that you can calculate the FL. So at any point of the liquid you can actually calculate this thing, the liquid fugacity. So liquid fugacity part you can actually check it out. Even at each iteration you can check it out what is the FL. Okay. So with that I will go to the assignment problem. You have your assignment, right? Assignment problem 3 I have given problem set 3, and if you look at problem number 3, develop problem number 4, estimate the vapor pressure of saturation pressure is asking for Psat of n octane at 427.85 Kelvin using the Payne-Robinson equation of state. The system pressure is given 0.215 megapascal. For n octane, TC is given, PC is given, 1 bar is given as 5 pascal, W is given, and Payne-Robinson equation of state alpha A and B are given. Fantastic. So everything is given in the problem. Let's see how to calculate Psat by using the same iterative procedure. We will be doing the same iterative procedure to calculate the Psat. So let's proceed further to calculate Psat. So I am asking you to calculate AT, which is ATC alpha I. We have the value of R, which is nothing but 0.45722 R square PC square divided by PC alpha. Critical point pressure is given 24.97 bar, right? Is it given? PC? PC is given 24.97 bar. TC is given how much? 568.14 degree Kelvin. Okay? R is we know 8.314 kilojoule per mole per degree Kelvin. Okay. So how much is your AT? How much is the AT? And please tell me the unit. AT unit you have to tell me. 8 unit you should tell me. And how to find out A unit quickly? How to find out unit of A should be what? Without having the marking the formula, you can tell me quickly from the equation of state. If you look at Van der Waals equation of state, it is P plus A by V square. That means A by V square unit should be pressure, right? So it should be pressure into volume square per mole square. That V is the mole volume per mole. So I am giving. So that's the way you should not do the mistakes of the units, because once you do the mistake, your answer will go wrong. So 80. How much is 80? How much is 80? What will be the unit of the 80? Any idea? First to decide the unit. First to decide the unit. Meter cube per mole square. And what is the unit of pressure here? Unit of the pressure here? Pascal. unit of the pressure is Pascal. Because it's in terms of Pascal. Okay? And also to make sure all the units, other things are correct. Pascal means Newton per meter square. Pascal means Newton per meter square. How much is the answer then? 80. 80 is very straightforward calculation. How much is alpha I? Before that I should be asking about alpha I. How much is alpha I? Alpha I to the power 0.5 is 1 plus mi into 1 minus tr to the power 0.5. Okay? And mi is how much? Mi is 0.37464 plus 1.54226 omega w minus 0.2699 w square. Okay? And w is also given 0.398. Please do the calculation. Don't be lazy. If you are lazy, then you won't get the answer. First calculate alpha I. First calculate alpha I. First calculate alpha I. I am not asking you to submit assignment for this thermodynamics. At least I am asking some minimum thing. Please do the problem in the class to help me. I am not asking you to do the assignment, but you can do it. You can help yourself is better. Okay. Please help yourself to. Please help yourself. What is alpha I? Alpha I is 1 plus mi into 1 minus root pr whole square. Am I correct? And this is 1 plus, how much is the mi? How much is mi? How much is mi? Mi formula I have given. This is there in your book also, exercise book. Mi formula is given. Have you all got mi formula? From Payne Robinson, PRUS, or you want me to write? See the situation. See, I'm telling you, I'm not asking to submit the assignment. Okay. So I just copy from my this thing. You go by that way. Entire problem I just copy. You don't without me to do. That means I don't know. Okay. So that's it. So that's our Indian. Sorry to our Indian academic system. That is the way. We cannot help it. 0.37464 plus 1.54226 omega minus 0.26992 omega square. I am sorry for your situation. And you have gone to that level. If I start giving assignment, asking for submission, then you say sir is bad. Torture. How much is mi? I was thinking that I would get so easily 80. When getting mi is I have to struggle so much.
Mi is 0.947.
9457. Then 1 minus reduced temperature. How much? 0.7514 whole square. How much it is coming?
The alpha is power minus 1/2. Alpha is
Minus?
1/2. Minus 1/2.
Alpha is minus 1/2.
Whole power. You are taking 2.
How much you got alpha? Just quickly give me the answer, then I will tell you.
So 1.26.
1.2677.
Yes.
Yes. So is square or minus half?
Because formula you have written.
Okay, that's the formula. Where you got minus half? I have given. I have given alpha like this. Minus half. Check in the book. Okay, check in the book. I think I have checked it. This formula. Okay. It is 1.2677. Okay. For time being, so you just go and check it. Then you will see the stuff. Okay. And what is 80? Actually, the formula I have what I've given correct. I think some maybe might have copied wrongly. The formula is alpha I to the power 0.5, which is 1 by 1 plus a mi into 1 minus tr to the power 0.5. That is the actual formula. So if you take the 0.5 here, it is not minus 0.5, it is square. This is the formula. I have the formula with me because I don't do that mistake. This kind of mistake I won't, because I have checked the computer program also. This problem. I cannot do that much mistake. This is the actual formula. Alpha I to the power 0.5 equals to 1 plus a mi into 1 minus tr to the power 0.5. And then if you take it out, of course it should be square, no? Correct? Yeah. Even if it is you are written wrongly, other earlier, please correct the formula. It is actually alpha to the power 0.5. So everything is correct so far. So what is 80? What is 80 then?
5.19.
So 80 is 5.197. I got 5.2024. 5.2024. B is 0.07780 RTC by PC equals to B unit should be volume unit, right? That's what you should be telling it. The first volume unit, it is meter cube per mole. Meter cube per mole. Meter cube per mole. How much it is? Meter cube per mole. Meter cube per mole. How much it is coming? PC is known, R is known. This is very straightforward. B calculation. B calculation is very straightforward.
So 1.475 into 10 power minus 2.
1.475 into 10 minus 4. Very correct. Okay. What is A and capital B? Quick. Capital A, capital B. A is AP by RT whole square. Capital B is BP by RT. Capital A is AP by RT square whole square. Capital B is BP by RT. Capital B is BP by RT. A is known, right? Once the units are decided, then don't worry about capital A and capital B units, they are all straightforward. R is known.
0.088.
Okay, I got 8.8398 10 minus 2. I always try to write like this. If it is more than 0.1, if it is more than 10 minus 1, I always go by this. It's better to do manipulation further. Capital B. Please try to give the exponent forms better. Capital B, BP by RT. Capital B, small BP by RT. Capital B, small BP by RT. Small BP by RT. 8.9151 10 to the power minus 3. Now apply the Carnot's method. In Carnot's method, what is the form? Cubic equation x cube plus alpha x square plus beta x plus gamma equals to 0. Right? Carnot's method. You have Carnot's method x cube plus alpha x square plus beta x plus gamma equals to 0. Alpha, beta, gamma. Alpha is what? My tabloids. I have given a table earlier. My tabloids, what's the formula for alpha? For paying the Robinson equation of state. Everything is there in exercise book. Minus 1 plus b. Please give me the answer. Beta is? What's the formula for beta? What's the formula for beta? A minus 2b minus 3b square, and gamma is minus ab plus b square plus b cube. Answer. Answer, please quick. Answer.
Alpha will be minus 0.991.
beta. Please use the memory function of the calculator. It's always better. Memory function of the calculator. Quick. Use the memory function of calculator. Use the memory function. Never any answer? It should be coming positive. It should not be weird. That's what I said. 10 to the minus 2 you should please write down. Please put after beyond this 7.0329 10 to the minus 2. And gamma is negative. Please check it out. Minus 7.0789 10 to the minus 4. So we'll start today evening from here, and then we'll show at least 1 or 2 iterations and just see how to proceed further. Thanks for attention.